values are ones that came out as significant. So for leatherbacks, you can see there's a negative significant correlation between in-nest temperature and incubation period, which is not unexpected. Also, ambient temperature and incubation period were also negatively significantly related. But what's really interesting, if you look on the bottom left box of the leatherback, is that sex likelihood and incubation duration are not significantly correlated, not even remotely. As well as the greens, on the flip side, there was mostly poor or even unrelated correlations, and once again, the sex ratios and the incubation duration, there's absolutely no correlation. What I believe is happening is that extreme rainfall events are happening. So if you remember the climate data that I showed you before, you had these huge peaks where we had some days where we were getting massive amounts of rainfall in one day. So if we go back to the raw data, I believe that this extreme rainfall event is being masked by mean and averages analysis. Here in this graph, the red line is once again I'm using leatherback as the example. The red line represents the theoretical pivotal temperature of 29.5 degrees. The black line on the bottom is non-nested sand, so controlled tidbit. And then the highlighted area, the circled area, is a day that we had over 100 millimeters of rainfall in less than 24 hours. And all of the nests had a significant decrease in temperature during that time. If you look and follow the aquatic colored or turquoise colored line, this is a leatherback nest that experienced this massive rainfall, and it happened during the critical temperature determining period. This nest dropped 3.3 degrees, so completely surpassed any transitional range for temperature determination that's been found in the literature. Also, furthermore, for greens, the massive temperature differential was 5.2 degrees Celsius. However, this happened outside of the temperature sex determination period. So in conclusion, obviously there are several limitations to my study. One being mainly that it's a low sample size, but also that I use theoretical pivotal temperatures. So to counter this, the study should be done to determine Playa Norte's actual pivotal temperatures. But I believe that the range I allowed for in my sex likelihood also somewhat helped encompass this factor. Secondly, nests succeeded even though they surpassed theoretical limits. So I believe, even as Ackerman said in the Biology of Sea Turtles Volume 2, that we still don't really understand the interactions of how exactly temperature and water potential and gas exchange, as Jack said before me, are functioning. Extreme rainfall events can definitely greatly affect in-nest temperatures. They can drastically drop these temperatures, which also reduces this at-depth buffer to extremes that nests experience. And it takes them a long time to recover from these drops in temperature as well. If this happens during a critical middle third, the temperature sex determining period, this may alter your sex ratios, and that should be taken into account when you're predicting your sex ratios. This is also going to greatly impact climate change predictions. One of the main things predicted in most of the climate change predictions is the change of where rainfall will occur. So if your rainfall patterns change on a beach that already experiences high rainfall, you may start encountering more lethal, like low nest success rates. But alternatively, if places like Playa Norte don't change, they may continue to be male-producing refuges. This is interesting because some literature has suggested using watering or shading as an alternative to increasing climate change, which of course is manually labor-intensive. And last but not least, incubation duration is not a good indicator of sex likelihood from this study. Thank you very much.